Hello folks, in this video I'll be discussing about virtual environments in Python. So if you've already worked with Python projects like any Django application or a Flask application or any standalone Python script, you should be familiar or you should have heard about the term virtual environment. So in this video, instead of focusing on in addition to focusing on the syntax of virtual environments, I'll be discussing about what is the need for virtual environment in the first place. Why is it needed? Why is that we just go ahead and create projects without virtual environment? What is the problem that could arise? Okay, so to understand virtual environments, we'll have to understand what a environment is. So in this video, this is what we'll be covering. We'll be covering what is an environment, what is a environment variable, the path variable, and what is the problem that we are solving, and how the solution is architected to solve this specific problem. So environments are like key value stores. If you have worked with any key value stores like the dictionaries or Redis databases, you have a key and you have some value associated with it. So you can think of environment as a key value store. Each key holds a specific value. For example, here as you can see, the variable first underscore name, it holds the value Magesh, and the variable last underscore name holds the value Ravi. So these individual keys, we call them as environment variables. Okay, so there are a lot of use cases for environment variables, but today we'll be focusing on the most important variable, which is the path variable. The path variable is what tells the system where to look for a specific application or a program. Let's say we open up the terminal and type Python 3, and immediately you get access to the Python REPL shell or the Python interpreter. So how does it do? Like this we all know that this Python 3 interpreter is stored as an executable somewhere deep inside the system. And how does the system know where this particular interpreter is located? Okay, so that is actually solved by the path variable. So the path variable basically holds a value, which is a list of folders to look for. So this path variable has a list of folders where the system goes one after the other to see, okay, these are the folders I have to look into whenever I am looking for a specific program or an executable or an interpreter. Okay, and these folders are actually separated by colon, not comma. So you have to make a note of that. And since the path variable determines where the Python executable is or the interpreter is, it in turns influences where the Python packages are also installed. The path somehow directly or indirectly influences where these new pip packages get installed. So this entirely affects your dependency tree and how your program is going to run. To understand the problem that we'll be facing, let us assume that you work on a Django project. Okay, this Django project uses the version Django 3.2, and initially you use the system-wide environment, and you say like, okay, this is the Python interpreter, and using this Python interpreter, I'm going to install Django 3.2, and the interpreter automatically collects Django 3.2 from your pip and stores in a secure location. And whenever you type Django-admin, it automatically goes back to this Django 3 package that you've installed. And a few months later, what happens is you start working on another project, and this time the Django version is 4.2. So the moment you install, you run pip install Django equal to 4.2, your new Django version is going to be downloaded, installed, overriding your version 3.2 package. So now what happens is your new project will run smoothly. However, your old project it's very likely to break because it was expecting Django 3.2, but instead you have replaced it with Django 4.2. And whatever new packages that come with 4.2 would have replaced your dependency on the Django 3.2 project as well. So To solve this problem, we'll use one environment for every project that we are going to work on. I have 5 different projects. I'll create 5 different environments. And let's say project A runs inside environment A, project B runs inside environment B, and so on. Okay. So this way, the dependencies and the packages are isolated from each other, and they are maintained separately. Python already has a few packages that help us manage virtual environments seamlessly. Some of the popular ones are VENV, Virtual ENV, and Virtual ENV Wrap. Before I get into the demo, word of caution, I'll be demonstrating this entire concept using my Linux OS, which is KDE Neon. It is based on Ubuntu 22.04 LTS. So I suggest you use either Ubuntu or KDE Neon as your primary OS. If you don't have a Linux OS and you're still working with Windows 11 and you're not comfortable overriding your Windows installation with Linux, I would suggest setting up WSL and then installing Ubuntu inside Windows, so that you get the best of both worlds. So there is a separate video on how to install WSL and how to install Ubuntu. We have also addressed some of the common problems that people face when setting up WSL and installing Ubuntu. Check it out. And in the demo, I'll be using VENV, which is a lot easier to set up. There's not much configuration needed. If you will be dealing with a large number of Python projects in the near future, I would suggest looking into virtual ENV wrapper. It takes a bit of configuration initially, but once it is all set up, switching between environments and switching between projects is a lot easier. So I also encourage you to watch the video on setting up virtual environment in Linux. So now let's go on to the demo part. Okay, so now I'm in my KDE Neon OS. I'm going to go ahead and open up my terminal. So first up, I'm going to check if Python 3 is installed. Python 3 version. Yes, Python 3 is installed. I would like to know where this specific Python interpreter is. So I'll use the command which followed by the command. So it says this Python 3 interpreter is within the folder USR bin. So how does the system know that you have to look inside the folder USR bin? This is provided by the path variable. So to print the value of the path variable, I'm going to go ahead and type echo $path. To evaluate any environment variable, we usually prepend it with the $sign. So echo $path is going to give me all the folders that the system is going to look into to find a specific application or a executable. So you can see there is USR local sbin, then colon, which means it's like a delimiter or a separator, and then there is another folder USR local bin, and then USR bin, so USR sbin, and then USR bin. So this is the folder within which this Python 3 interpreter is placed. Now going back to the example of having 2 different projects. So I'm going to create a new folder, dev/playground. Usually what I do is I create a folder named dev inside my home folder, and within that dev folder I have one project for one folder for every project. In some cases, when I want to do a quick demo or I want to test out a simple concept, what I do is I group them together inside the playground folder. So this command mkdir-p dev/playground is going to create a new folder named dev within the home folder, and inside the dev folder there is going to be another folder called playground. Okay, so I'm going to list all the folders using the command ls. So here you can see there is a folder dev. So I'm switching into the dev folder, listing the files again. So here you can see playground. So within the playground, I'm going into the playground. Now if I list, there's not going to be anything. So here I'm going to create a new folder for my project, for my Django project, which is going to run on version 3.2. Let's go ahead, mkdir Django 3.2 project. Okay, so I'm going to go inside mkd cd Django 3.2 project. Here what I'm about to do is I'm going to create a new virtual environment for this particular project using the command python 3-m venv. venv is the tool that we'll be using to create and manage virtual environments, followed by the virtual environment name. So here I'm going to use the name Django 3.2 env. Okay, unfortunately I've not installed python venv, so I'm going to do that. Sudo apt install python 3.10 venv. I'm going to key in my password. Yes, continue. This is installing Python venv package. It's ready now. To clear the screen. Now I'm going to issue the same command python 3-m venv followed by Django 3.2 env. Okay, so the virtual environment that I'm going to create is going to be called as Django 3.2 env. It's created. So if I list the files, you should see a folder named Django 3.2 env. So we have created the environment, but now I have to activate it. The command to activate it is source Django 3.2 env /bin/activate. So once it is activated, you can see the difference here. Before your username at host line, you'll see a string within a parenthesis. This is your virtual environment's name. So if you see something like this, it means that your virtual environment is now active. Okay, so now what I'm going to do is I'm going to check python 3 -- version. Yes, it's still version 3.10.12. However, if I run which python 3, you're going to see that it is not showing user bin python 3. Instead, it is pointing to your dev folder, playground, Django 3.2 project, env, and within that there is a python 3. So when I go ahead and let me clear this. So now when I go ahead and install Django 3.2, it is going to install this inside the virtual environment and not in the system level environment. Let's see that. Python 3-m pip install Django. I'm specifying the version name using double equals. It's installing the okay, it's installed. Let me go ahead and check Django admin -- version. So you can see that it displays the version as 3.2. Okay, so let me go ahead and create a I'll create a split view here. Let's go top bottom. Yeah. Okay, I'm going to clear this. So the terminal on the top, you can see that this virtual environment is active in this terminal. However, the shell session at the bottom, it does not have this indication, which means that this particular terminal is not having the this is not working within the virtual environment we just created. So if I type which python 3, you can see it as usr bin python 3, whereas here you see that it is picking up from within the environment we created. Similarly, if I run which Django admin here, I'll see the proper Django admin path here. Whereas if I run which Django admin, you should you should not see any value because we have not installed Django package outside the environment. Okay, so you see nothing. So you get the idea. This is here. The terminal at the bottom is working with the system level environment, whereas the terminal at the top it is working with the virtual environment we just created and activated. So let's go ahead and create another project here. So I'm currently in home dev playground. I'm going to create another folder, Django 4.2 project. Okay, so with it here, I'm going to create a new environment, Python 3 fnm env Django 4.2 env. So creating an environment called Django 4.2 env. It's going to take a few minutes or a few seconds. It's done. So I'm going to activate it by using the command source Django 4.2 env/bin/activate. Now we can see that this terminal is now working with the virtual environment we just created, and the one on top is working with Django 3.2 env. So I'm going to go ahead and clear these two terminals. Okay, so here in Django 4.2 env, I'm going to install Django, but the version is going to be 4.2. Yeah, it is done. So instead of typing clear every time, what I can do is I can simply press Ctrl L and it'll clear the terminal for me. Okay, so now I'm going to check Django admin -- version, and it's going to give me 4.2, and I'm going to check which Django admin, and it shows that it is from within the Django 4.2 environment. So this is how virtual environments help you isolate the dependencies between projects. I can also go ahead and show you which I'm going to use the command pip freeze. It is going to list all the pip freeze is going to list all the packages that are installed within the Django 3.2 environment, and here I'm going to issue the same command pip freeze, and this is going to list all the packages that is installed within the Django 4.2 env. Okay, so here you can see Django 3.2 and here Django 3.2, and here this is Django 4.2 and this is Django 3.2, and you see that Django 3.2 relies on an additional package called PyTC, which is a time zone package, and here it does not require it anymore. Okay, so these are subtle changes. If you don't maintain them separately for each project, at some point they get tangled and it's going to cause a lot of problem. I've seen a lot of experienced developers not maintaining the virtual environments correctly, then ending up wasting a lot of time debugging which packages are broken, which packages need to be replaced, and all that stuff. Okay, we are not affecting the overall system level environment. We are creating separate environments for each project, and within that we are installing all the necessary packages. Okay, I hope by now you have a good understanding of what a runtime environment is, and why is it a good approach or a good habit to have separate virtual environments set up for each project. If you found this video helpful, or if you learned something new from this video, please share it with someone who might find it helpful for them as well. Please do subscribe to our channel so that you can get notified about all the new updates that we keep rolling out in the coming days. Thank you.